Good morning. Okay, so let's take a look at exponential functions. This is day 2. So we're going to have different things going on with the function than we did on the first day. So the first part has a fraction and a base. So let's plug in what we have here. So we're going to plug in y equals, and we're going to clear out anything that's there. And we're going to have a half, so we can do 1 divided by 2. And then in parentheses, I'm going to do 3, I'm going to do parentheses, 3 caret x. And I'm going to right arrow out of that and close the parentheses. And I'm going to hit second graph. Okay, so let's see what I get here. And I'm looking for x equals 0. So for the x equals 0, I got 0.5. And at x equals 1, it says 1.5. And then at x equals 2, it says 4.5. Now it says find AROC. AROC stands for average rate of change from f of 0 to f of 2. So we have all that information. I'm going to make my mini table like I like to do. I'm going to do from 0 to 2. And at 0, it was 0.5. And at 2, it was 4.5. And I'm going to calculate how much it changes. So here it's going up by 2. Here it's going up by 4. And again, I like to do y over x. Here's my x and here's my y, or my x and my f of x. And I get 4 over 2, which is equal to 2 over 1, or just 2. So I got 2. So that's no different than doing it for a parabola. All right, let's check out here. Sketch the graph of the function g of x equals 2 times 3 to the x power. So this new thing is us having this number in front here, this number. Okay? So, and then we're going to do it here, where we're going to do 2 times 1/3 to the x. Here's 3 to the x. Okay, so let's go back into our calculator and let's plug in. Kind of edit this, what I have here, or I could clear everything out. I'm going to just delete out the 1 divided by 2, and I'm going to have 2, 3 to the x power. I'm going to hit second graph. Excuse me. Okay, so let's plug in some numbers. It doesn't really give me any numbers to graph. So I'm just going to graph whatever seems to look so pretty here. So I know at 0 it goes to 2. And 1 it goes to 6. 3, 4. Ooh, these. I graphed that wrong because it's counting by 2. So be careful there. I didn't see that. 0, 2, 1, 6. 3, 18, which fits because I'm going up by 2's. The 354 does not fit. Okay, but -1, 0.6, that's a little bit above the half. That fits. 0.2, so it's getting really close to the x-axis, but doesn't touch it. So by having this 3 here as the base, it's a little bit closer to the y-axis than the parent function, and the 2 also definitely affects it too. It makes it rise really fast. Okay, so we're going to call this g of x. Actually, I think I'm going to have to write that on the other side. Oops. Otherwise, my stuff's not going to fit here. Let's call this g of x. I'm going to graph the other guy, h of x, this guy right here in blue. So now I'm going to plug in y equals, and I'm going to clear this out. and I'm going to plug in 2 parentheses, 1 divided by 3 caret to the x power. I'm going to right arrow out of that and close my parentheses and hit second graph and get some values. So it definitely increases pretty quickly, or I cannot, I'm looking like at 1,458. I cannot graph that. I think I could probably graph -2, 18. I feel like that would fit on my graph. -2 and 18 is here. -1, 6 is here. Ooh, do you notice anything yet? 0, 2. Same y-intercept. This one's 1.6. So it's getting really close here, but not touching. And again, the 54 is definitely not fitting on my graph. So yours is going to look a lot better than mine. My graphs are not so great. This is h of x. So what's the y-intercept of g of x? It was 0, 2. The y-intercept of h of x is 0, 2. So what happens? It reflected over the y-axis. And the reason why we can see that is that, see, this is a 3 here. This is 1/3. They're reciprocals. So here is a Desmos link, which I can attach to my Google Classroom if you would like to play with it. Let's take a look at the next example. So now we have the exponential parent function a times b to the x. Where is the y-intercept? So it's at 0, comma a. So we used this as our parent function the other day, y equals 2 to the x. So there's really like a 1 in front of it. And it was at 0, comma, this y-intercept was at 0, comma 1. Okay. The prior one that we just did, it had a 2 in front of it. So it had 2 to the 3 to the x power, and the y-intercept was at 0, comma 2. So given the parent function y equals a times b to the x power, if the y-intercept is 6 and f of 1 equals 12, so we made this little table here. If the y-intercept is 6, that basically means it's 0, comma 6. That's how I got the first line. F of 1 equals 12, so we have 1, comma 12. We want to try and find the b, which is the base. So I'm basically plugging in the 6 in for the y, and I'm plugging in 0 in for the x. So I have 6 equals a, b to the 0. Well, anything to the 0 power always equals 1. And then I have 6 equals a times 1, or just a equals 6. So then I know that my 6 is in the front here. So now I'm left with y equals 6, b to the x. That's what I know. So what I can do, though, is now plug in the second point. And I'm going to plug in 12 for y and 1 for b. I'm sorry, 1 for x. I did that wrong. So I have b to the first power. So I have 6b equals 12, and I'm going to divide by 6, and I'm going to get 2 equals b, or b to the first power. So that's how I got my answer. So find the value of b. B equals 2. How do I write the equation? Y equals a b to the x. Well, we know a is 6. We figured that out. B is 2. And we have x there. So that's the equation that's going to give me 0, 6, and 1, 2. And that does make sense here. Remember we just said earlier, we said that the a value is your y-intercept. So there's my 6, and here it is. And then if I'm plugged in 1, 2, 2 to the first power is 2. 2 times 6 is 12, would give me 112. Okay. So let's try the next one. We're going to play a little bit around with this equation. Okay. So it says, given the table, write the exponential equation y equals a to the b, a times b to the x power. So the first thing I want you to do is to find a. Well, a is always the y-intercept. Do you see the y-intercept from the table? Hopefully you do. It's this guy right here. So a equals 3. So let's find, and even if we didn't know that, let's say we didn't know that. Okay, y equals ab to the x power, and I plug in 3 equals ab to the 0 power. Well, this is always equal to 1. So then we get 3 equals a times 1, or 3 equals a. That's one way of doing it. Okay, so let's take a look at finding b. Okay, so now we know y equals 3 b to the x, because we've just discovered that a is 3, so we plugged it in the front. Our goal is to find b, so I'm going to pick some other point on here. I'm going to go with this one because I feel like it's pretty, reasonable, 115. So I'm going to do 15 equals 3b to the first power, and b to the first power is just b. So 15 equals 3b. I'm going to divide both sides by 3, and I get 5 is equal to b. So that's my equals 5. Now that I know this, I can write, here's my generic formula. So y equals, I know that a is 3. I know that the base is 5 to the x power. And that's how I write the exponential function. Okay. And I can even put the base, if I wanted to, in parentheses, like that. Sometimes I write it like that. All right, let's move on to the next one. So can your calculator do this for us? Okay, so there is something. Remember we used to do linear regression to get the equation? That was kind of cool. So there's actually something called exponential regression. So what that means is that I can take the numbers that we were given in the table. And again, I don't have to have a lot of numbers, but the more I have, the better off I am. All right, so what I'm going to do is I'm going to go into my stat edit, and I'm going to go into my L1s and L2s. We haven't been in there in a while, so I would like you to clear out what you have in there by hitting the clear button. And you could do it on the top of L1, the top of L2, and just hit clear. And then you're going to plug in all of these values in L1. So I'm going to plug in -1, enter, 0, enter, 1, enter, 2, enter. And I'm going to go over in my L2 section. I'm going to plug in those. And I have 6, enter. I think it was 6. Was it 6? 0.6. I lied. 0.6. 3. 15. And 75. So now I have them all in here. I'm back to this guy here. Okay, so once I have my L1 and my L2 in there, what I'm going to do is I'm going to hit the stat button, and this time I'm going to go right arrow over to calc. And instead of hitting 4, which is linear regression, because this is definitely not a line, it's an exponential, okay? An exponential is a little bit lower, so I think it's choice 10 on my list. If I look, yes. So it actually has like a 0 there. So I scroll down past 9, it says expreg, and I'm going to hit enter. And then I'm going to hit enter a whole bunch of times because I have L1, L2, blah, 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 calculate, yeah, yes. And now it has this screen on there, which is giving me my exponential function. So it says a times b to the x power. Well, it tells me who the a is and who the b is. So I actually, all that equation solving that I just did for you, I actually don't even need to do anymore because the calculator does it for me. So I have 3 times, and then I could do 5 to the x power or something like that. And that's the same thing that we got. And it says type it into my Y1 and see if it matches my graph. I don't even think we had a graph. All right, let's take a look. I'll plug it in my L1. Y equals, clear it all out, 3, and then in parentheses 5 to the x power. And then hit second graph. And if I look at my table, bam, looks really nice. Okay, so let's take a look. Let's take a look at example number 4. So for example number 4, they're giving me a graph. Okay, so I need to find some points on here. There are some very specific points on here, and we can make a list. So let's find them. So I see -3, 2, 3, 4, 5, 6, 7, 8. -3, 8. That's this point right here. I see -2, 4. I see -1, 2. And I see 0, 1. That's enough points. I feel like I don't really know what these are exactly. There's some sort of a decimal. So I'm going to go with the ones that look like integer values. So now that I have those, I'm going to go into my stat and I'm going to go into 1 under edit and I'm going to plug in these points. So I'm going to clear out what's there. And I'm going to plug these in my L1 and L2. So I'm going to plug in -3, -2, -1, 0. Under L2, I'm going to plug in 8, 4, 2, 1. I'm going to hit my stat button. I'm going to go to calc, and I'm going to go all the way down to 0. And I'm going to hit enter, 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 enter a whole bunch of times. And I get that, so it's y equals ab to the x power. And it tells me my a is 1. And it tells me my b is 0.5. And I can write this a different way. I can write it as a 1, and I can write this as a half. Or I can even forget that 1 in the front, and I can just write 1/2 to the x power. So does that actually make sense? If you look at the picture, it's reflected over the y-axis, and it's the parent function. And this is the reciprocal of 2. So it actually does make a lot of sense. All right, so let's move on to silver and gold, and let's see how we do. So I'm going to head to silver first, and then I'll do the sum it up, and then we'll do gold in the end. Okay, so let's take a look at silver. Silver says, what is the average rate of change for S of x equals 5 to the 2 to the x power over the interval from 0 to 2? Okay, well, the first thing I need to do is I need to generate a table. So I'm going to go into my y equals, I'm going to clear everything out, and I'm going to plug in 5 parentheses, 2 close parentheses to the x power, and I'm going to generate a table. And it's asking from 0 to 2. So I'm going to create a table, and I'm only going to look at those values. I don't really need to know anything else. So for 0, I got 5, and at 2, I got 20. Hopefully you're getting the same as me. It's going up by 2, up by 15, and if I did 15 over 2, I would get 7.5 as my average rate of change. What is the average rate of change for r of x? It says for 2 times f5 to the x power. So that's totally different. So y equals, and it's going to be a 2 and a 5 to the x power. And I'm going to generate a table that way. And it's also from 0 to 2. And at 0, I got 2. And at 2, I got 50. That's a lot. So it's going up by 2, up by 48. Hopefully you can read that. And I'm going to do 48 over 2, which gives me 24. as my average rate of change. Which function has a faster rate of change over the interval from 0 to 2? Well, definitely the second one. 24 is much higher than 7.5. All right, so I'm good with average rate of change. Hopefully you are. Write the exponential equation for the table in f of x equals a times b to the x form. So here's my lovely table. So I am going to go into my stat button, into 1, into my L1 and L2s. I'm going to clear out what's there. And I'm going to plug in these points. So I have -1 in my L1, 0, 1, 2, 3. I think you need to have at least 3 points. We have 4, which is great, but 3 is probably the minimum that I need. 8. So I have 16, 8, 4, 2, and 1 going in my L2. And then I'm going to hit stat, and I'm going to right arrow over to calc. And then I'm going to go all the way down to choice 0 or exponential regression. Hit enter a whole bunch of times. And bam. So they give me a b to the x like this. And that tells me that the a is 8. And it says that the b is 0.5, or you can even write a half if you want to the x power. So I'm good with that way, or I can even write it as 8 times a half to the x power. So this or this works for me. All right, so let's head to the sum it up, and then I'll go back to gold afterwards. So let's talk about the sum it up here. Sum it up's a little challenging. It says graph the function f of x equals 2 to the x plus 3. So hopefully we know that this is inside and it's lying. So it's moving the parent function and it's shifting it to the left 3. So hopefully you know that. So let's plug it in. I'm going to clear out everything that's here. 2 caret, and then I'm going to do x plus 3. And I'm going to hit second graph. I'm going to get some points for me to graph. And I'm going to I'll start with -5 a quarter. 1, 2, 3, 4, 5 a quarter. -4 positive a half. -3, 1. -2, 2, -1, 4, 1, 2, 3, 4, 0, 8, 5, 6, 7, 8, 1, 16, 9, 10, 11, 12, 13, 14, 15, 16. Nothing else is really going to fit in quadrant 1. And hopefully here you're recognizing that the asymptote, the one that's going near, is the x-axis. And this is called f of x. Okay, it says write the exponential function in y2 in your calculator. So it says if the y-intercept is 8 and g of 1 equals 16. So they're going to go back down here. So the y-intercept is 8. So do you remember when we did this before? Y equals a b to the x. And we said the y-intercept is your a. So if I did y equals 8, here, y equals 8 b to the x. So this is 0. Y equals 8. B to the 0 is 1. So y equals 8. That's my y-intercept. So what I'm going to do is I'm going to try and figure out what my b is going to be. So it says g of 1 equals 16. So now I have y equals 8b to the x. And I'm going to plug in 16 for y. And x is 1. So 16 equals 8b1 or 8b. I'm going to divide by 8. And I'm going to get 2 equals b. So 8 times 2 to the x power. So let's talk about how this is related to what's up here. So it's a little bit of a stretch, but it is the same. So if you look at this, it's 2 to the x plus 3 power. So I don't know if you remember anything about the laws of exponents, but you add the bases when you add the exponents when you're multiplying like bases. So basically this is the same as 2 to the x times 2 to the third power. That's what this means, technically. I don't know if you remember that from 7th grade in laws of exponents. But you're basically, if you have the same bases, you would add the exponents. It would be x plus 3. Like if this was 2 squared and 2 cubed, it would be 2 to the 5th power. So this is 2 to the x plus 2 cubed, and it's really 2x and 2 cubed. Well, what is 2 cubed? 2 cubed is 8. Aha, that's the 8 that's here, times 2 cubed. That was a little hard. So what do you notice? 2 cubed equals 8. Same function. So if I plugged in y equals, so I'm going to do that on my calculator right now. So in my calculator, I currently have 2 to the x plus 3 on y1. Under y2, I'm going to plug in 8. And then in parentheses, 2 close parentheses to the caret 3. And I'm going to generate a table. And I definitely plugged that in wrong. Hold on. I forgot my x. 8 to the x power. That's what I did wrong, not 2 caret x. And then I'm going to generate a table. And I actually get the same exact table from my blue and my red values for y1 and y2. So it says, what do you notice? 2 to the third equals 8. What is 2 to the x times 2 to the third? It's 2 to the x plus 3 power, which is what I explained up above over here. All right, so that was difficult. All right, so Silver Friends, you're going to stop the video here, and you're going to move on to the homework. My gold friends are going to head back with me to gold. So let's take a look at gold. All right, so gold, it says, what is the average rate of change of p of x from 8 to 1/2 x from the interval of -2 to 2? Okay, so I'm going to do -2 to 2. And we're going to plug this in our calculator. And if I plug in y equals, and then I have 8 parentheses, 1 divided by 2, close my parentheses, caret x, and I'm going to plug this in and I get -2. And if I look at -2, I get 32. And if I look at 2, I get +2. So this is going up by 4. This is going down by 30. So again, I'm going to do y over x, and I would get -7.5. I'm making that a big negative sign so you can see it. What is the average rate of change for q of x, which is 4 times 2 to the x power? So I'm going to do a table for that. I'll do it in a different color. And I'm going to plug y equals 4 parentheses 2 close parentheses caret x in my calculator. And I'm going to look from -2 to 2. And at -2, I get 1. And at 2, I get 16. So here again, it went up by 4. But this time it went up by 15. If I did 15 over 4, I would get 3.75. Which function has a faster rate of change over the interval? And the correct answer is the first one, p of x. Write an exponential equation for the table in the form f of x equals a b to the x. Okay, so you're going to plug this into your calculator. So this is actually the same as silver. I'm pretty sure it is. So you're going to hit stat, and you're going to do edit, and you're going to plug all of the x values in your L1, and you're going to plug all of these values in your L2. And then, just give you a second to catch up to me because I have them already in there. And then you're going to hit Stat Calc. So you're going to right arrow over to Calc. And then you're going to go all the way down past number 9 to 0, which is exponential regression. This guy, exp reg. And you're going to hit that. And it currently gives you this. And this tells me that my A is 8 and my B is 0.5. So you can write it like that. That's one way. Or the other way, I told Silver Friends you could do 8 and you could do a half to the x power. Doesn't matter. I'm good with either one. All right, so Gold Friends, we're done too. Stop the video here. Work on your homework. Have a great day.